Okay, so before we delve into one more piece of new content, and that's contrast coding, let's review what we've already learned. So first question, why do we need codes or vectors in regression? Well, first of all, when we need them is when we have a categorical variable that has more than two groups. So if we have, remember, two groups, we're fine just entering it in coded as a 0, 1. Usually, 0 is the absence of an attribute and 1 is the presence of it. So if you're introducing a new kind of intervention, for example, you would put the control group as a 0 and the intervention group as a 1, because that's just easiest, I think, for interpretation for the reader. But for things like gender, etc., it doesn't matter which one you code 0 and 1, just so long as the reader knows when they're looking at your regression table which one you did code, 0 versus 1, because that is going to matter for the interpretation of that analysis. So it's important to note that when you do a dummy code, you have to, at the bottom of the table in the notes section, indicate to the reader how you coded that categorical variable in the analysis. So you would say 0 equal female, 1 equal male, or vice versa, and you would put that at the bottom of the table. Because if you didn't put that, then the reader won't know how to interpret the correlations or the B weights. The second question is, if a categorical variable has 5 levels, let's say you're analyzing across 5 different organizations and you want to understand mean differences among them, how many dummy codes or vectors will be needed to fully represent that predictor? And the answer is 4. So you take your number of levels, and which would be lowercase n, and you would subtract 1, and that would be the number of dummy codes that you need. Do we need to code dichotomous or binary predictors? No, the answer is we do not. All we need to do is set them to 0, 1 and put them right into the analysis as they are. It's great. There's no pre-work needed for those. When dummy coding, what does the constant represent? The constant represents the mean of the DV in the reference group, whatever you made that to be. The B weights in dummy coding represent the differences from that group to the reference group. So it's a comparison of that particular group to the reference group. So if that code has reached significance, we know that that group differs significantly from the reference group. And remember that the B weights are equal to the focal group's mean minus the reference group mean. So that means if that sign of the B weight is negative, we know that that focal group has a smaller mean than the reference group. If it is positive in sign, we know that it is more than the reference group, because when you subtract the reference group off of it, you have a positive number. Okay, so keep thinking about that. Keep thinking about that formula, focal group minus reference group. What does it mean when the final outcome is negative versus positive? And of course, all of this is dependent on which one you made the reference group. Finally, what are some rules for an adequate reference group in dummy coding? So what does a proper reference group look like? Well, recall that it needs to have a large n size compared to the other groups. It should not be a category that has only a few people in it or a few units in it. And it can't be like an other category or a non-applicable category. It should be a legitimate category. And finally, when you're thinking about your hypothesis or your research question, you want to compare all the other groups to it. So it makes sense to make this maybe the control group if you have an intervention with various levels. But really, it's any of the levels of that category that you think are meaningful and will differ significantly from the others. So those are the things that you want to keep in mind when you are deciding which group to make the reference group.